Welcome to homework.
So we're given two acids, HClO4 and also HIO. And we find that HIO4 is much more stronger in terms of acidity than HIO. So what would be the two factors that are affecting the acid strength, the acid strength between these two acids? So first of all, let's draw out the chemical, the Lewis structure. So you have a chlorine bond to three oxygen, and then also with a hydroxy group or OH group. And then for HIO, we have the same group but bond to our aldene. So the first factor that we are looking at is that we're looking at the presence of highly electrolytic species. Okay, but before we move on to look at the number of how the number of electrolytic species are affecting the acidity. So first of all, we have to have a look. Okay, for acid, so essentially they are the molecule that contain a hydrogen bond to something else, and due to the structure on the bonding, then the nature of the bonding, then the bonding between hydrogen and the rest of the molecule will become weak. So if it weakened by different kind of reason, so that's why when it is going to have interaction with water or maybe with other substance, this bond tend to be breaking, and then it will produce a ion, hydrogen ion, and that's because S is a proton donor, so that's why uh, this happened. So therefore, if we have a stronger acid, the bonding over here should be much more weakened or much more weaker. If we can buy something else, it's much more weaker, we can buy something else. Okay, so when we come back here, we're looking at what kind of factor affecting the strength between the hydrogen. We are actually looking at the hydrogen and the oxygen bonding on both molecules. So for HClO4, we can see that it have chlorine and also four oxygen. So we have a lot of electrolytic species that can pull electron density uh, from the bonding between hydrogen and oxygen. So therefore, when we have more electrolytic species to pull the electron density from our um, hydrogen and oxygen bonding, then the bonding between hydrogen and oxygen will be weakened. So it will be much more easy to break. So it will become a better proton donor. So that's the first factor. It will be the number of electrolytic species or atom bond to our molecule. Okay, so at the same time, we can see that for HOI, we only have oxygen bond to the hydrogen and also only aldene. So aldene relatively is not that electronegative when compared to chlorine, and also we only have one oxygen over here. So the electron density pooling effect due to the different electronegativity is not as pronounced. So that's why the bonding between hydrogen and oxygen is still kind of strong in HOI. So that's why it's strong, hard to break. So you dissociate less. So that's why the acidity will be smaller. Okay, for second factor, we are actually looking at the structure of the conjugate base. So we actually looking at the stability of the conjugate base. So if the stability of the conjugate base is not stable, then we will be much more reactive. It will react with another species. If one is proton back, so it will go back to its acid form, and then the overall ionization percentage will be low. So for the conjugate base of our core for our perchlorate ions, so it looks exactly like that. So because we just lose one proton, so we have less charge on the molecule. But if you pay attention for these perchlorate ions, you can see that the charge, although it look like on this oxygen, but it can be go to the west of the oxygen by Western's effect. So the charges can be delocalized on this molecule. So that's why you can make the charge not center at one point, so you make the molecule or the molecular ion much more stable. But on the other hand, the conjugate base, we have the negative charge concentrated on the oxygen. Although the iodine can sort of help a little bit to just help a little bit to pull the electron density away, but again, still oxygen has a higher electronegativity. So that's why the electron will tend to stay with oxygen. So for this case, charge will concentrate on oxygen. So we have a really high charge density. So that's why it's able to grab a proton to attach to something positive, especially with a proton, to go back to our HOI. So for this case, the ionization percentage will be much more lower for HOI, but for perchlorium, will be much more higher.